Find the HCF of 96 and 404 by the prime factorization method. Hence, find their LCM. Okay. So we have to find HCF. First, we have to find HCF of this 96 and 404. So using HCF, we have to find the LCM like that. So so they have given the method also. So prime factorization method. That means we have to prime factorize this number and this number. Then we have to find the HCF like that. Okay, we'll start. So first I will write prime numbers starting from 2. Prime numbers means so the number which is having only 2 factors. That means only 2 numbers can divide this 2 completely. First 1, next to the same number 2. So this can divide this completely, this can divide this completely. Only 2 factors, no other number can divide this 2. So that's why this 2 is the prime number. So prime number is having only 2 factors like that. Okay. So first write prime numbers starting from 2. So first 2. Okay. After that next 3, next 5, next 7, next 11 like that. So numbers will continue. These are the prime numbers. Okay. Order of the prime numbers. Okay. Now we have to find we have to factorize. Take 96. 96 is equal to, we have to write this 96 as a product of prime numbers. So for that we can find the prime numbers by dividing this 96. So first write 96, write like this. So just check whether this first take the first prime number. So take the first prime number, check whether this 2 can divide this 96 completely or not. So this 2 can divide this 96 completely. So take this 2 right here. So 248 is the 96 we will get. So for this next you put like this. Again check whether say this 2 can divide this 48 or completely. Okay. Don't go for next numbers. If this don't divide this, then you have to go for next. But first you have to check this. So now this 2 can divide this 48 completely. So I will write same 2 here. And now 224 is the 48. Next for 24 put like this. Next again check whether this 2 can divide this 24 completely or not. Yes, this 2 can divide this 24 completely. So write this 2 here. Now 2 12s are 24. For 12 again you put like this. Next check whether this 2 can divide this 12 completely. Yes, this 2 can divide this 12 completely. So take this 2 here once again. So now 2 6 the 12. Again put 6 for 6 like this you take. Again check whether this 2 can divide this 6 completely. Yes, this 2 can divide this is completely. So write this 2 here. Now 2 3s are 6. Again for 3 you put like this. Again check whether this 2 can divide this 3 completely or not. No. 2 cannot divide this 3 completely, because if you divide 3 by 2 you will get 1.5, which is decimal. We should not get like that. So 2 cannot divide 3 completely. So we will check the next number, next prime number. Next prime number is 3. So see, this 3 can divide this 3 completely. So I will take this 3 here. Now 3 ones are 3. So when you get 1 here, you stop the division process. Now except 1, whatever is there, okay, except this one, whatever the prime numbers are there, these prime numbers used to divide. So except 1, take all this, first write 2, next this 2, leave some space, next this 2, between space you leave, next this 2, next this 2, next this 3. Now between the numbers, so you put into 8. So into means multiplication, or we also call that as product. Now this is, and 2, they are the prime numbers. So this is product of the prime numbers. So we have written 96 as product of prime numbers, because CP multi 2 2 is a 4, 4 2 is a 8, 8 2 is a 16, 16 2 is a 16 2 is the 32. So 32 3 is a 96. So this is prime, this is called prime factorization. That's what they, in the question they are telling, prime factorization method. So this is the prime factorization of the 96. Okay. Now similarly we have to prime factorize the other number 404. So next number is 404 here. So to find the prime factors, we have to divide this 404 from these prime numbers, like how we did for this 96. So this 404 you write here, put like this. Now check whether this 2 can divide this completely or not. Yes, this 2 can divide this 404 completely. So I will take this 2 here. Now see, 2 202 is a 404 we will get. Next, and then for this put like this. Next check whether this 2 can divide this 202 completely. Yes, this 2 can divide this 202 completely. So I will take this 2 here again. Now 2 101 is a 202. Next, now put like this for this 101. Now see, 2 cannot divide this 101 completely. So next number is 3. 3 also cannot divide this completely. 5 also cannot. 7 also no. 11 also cannot divide this completely. If we keep going on, there are many prime numbers. So there are many prime numbers. If you take many prime numbers and you try to divide this, so many prime numbers won't divide this completely. But this 101 can divide this completely. 101 101 101. Okay. So when you get 1, you have to stop the division process. So except this one, so whatever the prime numbers are there, whatever the prime numbers used for division, so take this and write here. First 2, leave some space, next another 2, next leave some space, next this 101. So in between numbers put into. Now see, we can see into means product. These are the prime numbers 2 to 101. So this is product of prime factors. So 404 is written as a product of prime factors. If you multiply this 2 to the 4, 4 into 101, you will get 404. So this is called prime factorization. Prime factorization of the 404. So that's what question says, prime factorization. Okay. So now using this and this, we have to find the HCF now. So for finding HCF, there is a definition for the HCF that I will write now. So using that definition, we can find the HCF. So this is the definition. Product of the smallest power of each common prime factor. Common prime factor in the numbers. So here I will take same thing like HCF is equal to. You have to use this definition. First numbers. Numbers means you have to consider both the numbers 96 and 404. Okay, now common prime factor. So these are the prime factors 2, 2, 2, 3 and here 101, 2, 2. So what they are telling, common prime factor. We have to take a common prime factor. That means here and here, whatever common, that you have to take only once. First check this 2. Whether take this 2, check whether this 2 is present here also. Yes, present. See here also 2. So here also 2 is here and here also, that is common prime factor. They are telling each common prime factor. I mean, if there are 2 common prime factors, you have to take 2. If there are 3, you have to take 3. Every common factor you have to take. So that's the meaning of each common prime factor. So first we check 2 is here, 2 is here also. So 2 is common here and here. So that right here 2. Next check 2. 2 is already taken. Only once you have to take. Next 2 is there already. Next 2 is said. Next 2 we have already taken. Next 3 you take. No. 3 is here, but here no 3. So you should not take here. We have to take only common prime factor. Okay. Common means that number should present here also. But 3 is here only, here no, here not there. So don't take 3. Next 2 taken, 101. 101 is here only, but here no 101. So 101 is not common here and here. 101 present here only, here 101 not there. So we have to take a common prime factor. So don't take this. Next to consider this product. Product means multiplication. If there are 2 numbers, we can multiply. But here there is only one number. So don't put any into or something. Because only one number. So don't bother about this. Next what they are telling? Smallest power. So power. So for power, first we have to simplify this. See how many 2's are there? First write this 2. How many 2's are there here? 1, 2, 3, 4, 5. 5 2's are there. So we can write 2 to the power of 5. After that into this into next 3. How many 3s are there? Only 1. So 1 you write here. So these are the powers. 3 to the power 1, 2 to the power of 5. 5 and 1 are the powers. Next here also 2 you write. How many 2s are there? 2. This is 1 2, this is second 2. So 2 2s are there. So that 2 you have to write. 2 to the power of 2 means there are two 2's like that. Next into 101. How many 101? First write this 101. How many 101s are there here? Only one. Only one 101 is there. So that one you write here. Now come to this power. That means you consider the powers. These are the powers. So what they are telling? Next smallest power. Okay. Smallest power of each common prime factor. Power of what? Common prime factor. So common prime factor is 2. Common prime factor is 2 and we have to consider smallest power. That means common prime factor 2, right? So consider 2. In both here and here also 2 you consider. Here 2, here also 2. So powers you consider. So power of this 2 is this 2. Power of this 2 is this 5. Next what they are telling? Smallest power. So which power is smallest? Whether this 5 or 2. So 2 is smaller than 5. So 2 is the smallest. So this 2 you write here. Okay, now 2 square means 2 into 2. That is equal to 4. Okay. So now 4 is the answer. HCF is 4. This is the answer. After this continuation is there. See, next to hence find their LCM. That means hence means using this HCF find LCM. Okay. See, for HCF they told prime factorization method. But for LCM they are not telling a prime factorization method. They are telling hence find their LCM. That means using HCF and using formula. Using HCF and formula find LCM like that. They are not telling find LCM using prime factorization method like this. They are telling use HCF and formula find LCM. So that is the meaning of hence. Okay. So we will find LCM using this HCF. Okay. So there is a formula. I will write here. LCM of AB. AB means they are numbers into HCF. HCF of AB is equal to A into B. Okay. So this is the formula, LCM HCF formula. This formula you have to remember. A and B are numbers. In this question, which are the numbers? 96 and 404. So this is A, this is B. Or you can take this is A, this is B, no problem. So I will take this is A, this is B. So A is equal to 96. I will write here. A is equal to 96 and this B is equal to 404. Substitute A and B values here. So LCM of A comma B means 96 comma 404 into next HCF A comma B means 96 404 is equal to A means 96 into B means 404. So we want LCM of this. So LCM of 96 comma 404. We want LCM because we have to find LCM. So into, you write as it is, HCF of 96 404. So we got right 4. So this is the answer. So in place of this, we will put this 4 because HCF is equal to 4. Next is equal to, I will write as it is 96 into 404. Okay. But actually equal sign should be in one line. Okay. But here because of space I have written here, but in exam you write in such a way that equal sign should be in one line, one below of the other, like that you write. Next what I will do, so we want LCM, we don't want this 4. So to remove this I will divide both sides by 4. Okay, so this 4 cancels out. Now whatever is there, write it here. So LCM of 96 comma 404 is equal to, now see we can divide, into is there, we can divide this by 4. So 4 ones are 4, 4 101s are this, 4 ones are 4, 4 101s are 404 will get. So we can divide like this. What we are left, so 96 into 104. Okay, so if you multiply this 96 and 101, you will get this 9696, 9696. Now so this is the answer. So LCM of 96 404 is this. So HCF we got 4, right? We got 4. So find the HCF dash. HCF is 4. LCM is this. So this and this are the answers for this question. Okay. Yeah, that's all. Yeah, anything if you want to say related to my teaching and this concept, please mention in the comment. I will follow that. Okay, thank you. Subscribe.